Okay, this lesson will be about determining empirical and molecular formulas from data in a question. What's an empirical and molecular formula? Well, remember that the empirical formula is expressing these numbers here represented by x, y, and z as the lowest whole number ratio of the mole ratios, or just the atomic ratio among those atoms that make up that sample. And a molecular formula, it's not necessarily the lowest whole number ratio, it's like the literal ratio of how many of each of those respective atoms you would find in a molecule of that compound. Okay, so let's determine some empirical and molecular formulas from data. All right, here we go. The empirical formula of maleic acid is CHO. What does that mean? Basically, you can interpret that like C1H1O1. Okay, they're in a 1:1:1 ratio. If its molecular mass is 116.1 grams per mole, determine its molecular formula. So we're basically looking for, like, we have to scale this up, right? You know, possibly. I guess it could end up being that the empirical formula is the same as the molecular formula. But we're going to have to scale this up. We're going to have to probably most likely multiply this by some multiplier. So we're trying to figure out, like, what's the multiplier? Okay, what's the multiplier here? How are we going to figure that out? Well, we'll have to first determine what we might call, you know, it doesn't really matter if you use this term or not, but the empirical mass is what I call it, what it's commonly called. So you take the empirical formula and you say, if that were the molar mass, okay, if that were the actual molecule, what would the mass be? So look at the periodic table. Carbon is 12.01, hydrogen is 1.01, and oxygen is 16.00. Total that all up, you get 29.02 grams per mole as the, like, theoretical, you know, empirical mass, if you will. Okay, so to figure out what the multiplier is, then we're going to take that, like, you know, I don't know what to use as a short form, the empirical mass, EM, just making that up, not an official symbol or anything. We're going to take that empirical mass, we're going to put it underneath. We're going to divide the actual relative molecular mass that we are given, that's the 116, and we're going to divide that by the empirical mass. So that'll give us, like, what the multiplier is, hopefully. Hopefully this turns out to be like a nice whole number. That would be lovely. Okay, so pump it all in there, and never mind my ugly writing. And if you do that, you get roughly 4. Okay, phew. So this means we basically are going to end up multiplying that every subscript in the empirical formula by 4. So that means in the end we would say the molecular formula for this certain compound, which is called maleic acid, is C4H4O4. Okay? Da-da, da-da, da-da. Okay, we're up against this one. Ethanoic acid is found in vinegar. True fact. It's about 5, normal table vinegar is around, or like white vinegar is around 5% ethanoic acid. You can have more potent vinegars that are, up to 9 or 10% ethanoic acid, but ethanoic acid is found in vinegar. It's 40% carbon, 6.71% hydrogen, and the rest oxygen. It has an MR, it says, so that's the relative molecular mass, of 60 grams per mole. Determine the empirical and molecular formulas. Okay? So first off, there's a few assumptions we have to consider here. So when it says it's 40% carbon, 6.71%, and the rest oxygen, we're going to go ahead and assume that that means by mass. Okay, if they give you these numbers, we're assuming that means those are the percentages by percent compositions by mass, right? Okay, so we should easily be able to, subtract those given ones from 100 and find how much percent the oxygen is. That shouldn't be too big of a deal. So how do we go about finding this? Well, first we have to find the empirical formula. So to do that, we're going to do a little move where we assume there's 100 grams. If we assume there's 100 grams, then those percent compositions by mass will just correlate perfectly to an amount of grams. Once we have a set of amount of grams, we can convert those into moles, because an empirical formula shows you a mole ratio. So I'll go through that and lay that out for you. So let's assume there's 100 grams. That means for carbon, there is going to be 40.0 grams. Okay, that means for hydrogen, there would be 6.71 grams. And that means for oxygen, there's whatever 100 minus 40 minus 6.71 is. Punch that in, it's 53.29, I believe. 53.29 grams, or 53.3. I'm not going to be too picky right now with significant figures. Let's just roll with it. All right, so there's our masses, assuming we have 100 grams, okay? And we did that to find that. All right, now what we're going to do is convert those to moles. Convert to moles. And the reason that we're going to do that is because we know an empirical formula shows a mole ratio, okay? So I can write this here, because, and, well, it kind of says because. It says because, like sauce. Convert to moles because empirical formula shows a mole ratio. Formula shows mole ratio. So does the molecular formula, for that matter, but it shows the lowest whole number mole ratio. Anyways, we got to convert them to moles, okay? So how do we do that? I'll do that, well, let me do that in a different color. Maybe that way I can save some space. So in doing that here, we're going to have to divide each by their respective relative atomic masses. So you look at the periodic table and you pick that off. It's 12.01 grams per mole for carbon. It's 1.01 grams per mole for hydrogen, and it's 16 grams per mole for oxygen, okay? Then you go ahead and crunch those numbers. You'll get it's 3.33 moles of carbon. It is around 6.64 moles of hydrogen, and also around 3.33 moles of oxygen. Now the move is to divide each of those number of moles by the lowest number, okay? And in doing that, you're going to be able to get the lowest whole number ratio, okay? So then we're going to divide by the smallest. Divide by smallest. Okay? So divide them by 3.33. Two of them are going to work out then to be ones. And this one is roughly going to work out to be 2. Okay? And we do a little bit of like rough guesstimate kind of stuff for this. They should work out to be whole numbers. If they don't, if they're off by a minutia, it's probably just because of significant figures that we didn't carry enough digits forward in our calculator and we got little kind of compounding errors. But anyways, from this, we should be able to figure out that the empirical formula then is C1H2O1, right? That's the empirical formula. Okay. All right, so now we take that and we have to figure out the molecular formula. So can we slide this whole thing up? Hang on a second. Okay, I'm not so slick at sliding it around, so I just fired it on another slide here. So we have our empirical formula we just determined. We have our molecular mass. We're going to use these to find the molecular formula. So like we did in a previous example, we're going to find the empirical mass here, okay? So if, theoretically this thing were just made of a C, 2 H's, and an O, what would the mass be? It would be this, right? Which is 30.03 grams per mole. This is like a theoretical value. All right, so then we're going to take the actual molecular mass here of 60, and we're going to divide it by this empirical mass, and that's going to give us our multiplier. So this is to determine the multiplier. To determine the multiplier. All right, and away we go. And when you do that again, hopefully you get a nice whole number ratio. And I think you can see here that this thing is shaping up to give us that. Oh my Lord, I can get pretty messy on this thing. Okay, and it gives us about 2, doesn't it? Okay, so our multiplier is 2. So what's that mean? Go ahead and make sure you answer the final question. That means you have to multiply the whole empirical formula by 2. So therefore, the molecular formula at the end of the day is C2H4O2. Okay? That should be the final molecular formula. Now, if you remember, this question happened to be about ethanoic acid. You might happen to remember from what you've done in organic chemistry that ethanoic acid is a simple carboxylic acid. It's kind of outside this topic, but why not? They should be able to draw it. It's 2 carbons. It has a carboxyl group on the end, and then you fill out the hydrogens. Does that have the molecular formula of C2H4O2? You bet your bottom dollar it does.